Okay, so today we're talking about programming. In particular, we're going to be looking at validation for user input in this video. So a system starts with your input. Okay, the input might be data, or it will be data, and that data is then processed, okay, by the system. It might manipulate that data in some way, or that data might be to print something out, or whatever it might be. Okay, so it performs that process, and then output is the result. It could be output to your screen, it could be output physically, it could be output as sound, it could be a number of different things. So, as an example, input an ATM machine, you input your PIN code, you input your physical bank card. The process that might occur is the update of your account balance after you withdraw money. So, you've input your card, input your PIN. You input, okay, I want to withdraw $20. The process is it takes $20 away from your account, checks that you have enough money to do that, I suppose, as well. And then the output is the money that you asked for. Okay, that's your basic system input, process, output. Okay. Now, the problem, I suppose, is potentially bad input that could occur. So imagine that you are designing this application. And you can just see there, imagine you're on the help desk and you've got a call and you're just thinking to yourself, yeah, okay, let's just deal with this one. Yeah, you need to type the number 20 in. And then on the other end, the other guy is saying, yeah, no, I've typed the number 20 in, TWENTY. And that's why we need to validate the data and make sure that the data is good. The ATM obviously has an interesting way of doing this. You can't type the letters in for 20, but on a computer you could. So it presents an interesting issue there that needs to be validated. Another example is, you could have someone say, oh, the computer asked me if I would like a small, medium, or large, and so I said big, right? Because it makes sense. Everyone knows what I mean. But the computer doesn't. The computer's asked for small, medium, or large. Like, why would you do that? Yeah. A human would understand you, a computer would not. So how do we stop users from making these mistakes? Well, we need to guide users to give us the input that we want. We need to validate the input that they give to make sure it's what we want. And there are a few ways we can do that. So one way is we can limit the options the user have so that they only can give us what we want. Alright, so using some Visual Basic examples here. The radio buttons, okay, small, medium, or large. There is no possible way you could tell me you want big. Okay, that would confuse my processes of my system, so I'm only giving you the option of small, medium, large. I haven't given you a text box because who knows what a user might type into that. Now, checkboxes, tomato, mustard, mayonnaise, okay? Now, the main difference here, radio buttons, you can only select one, okay? Checkboxes, you can select multiple, alright? So, you might want tomato and mustard on your hot dog or whatever it might be. Drop-down lists as well. Again, just another option of how you can limit that user input. The ATMs obviously have their own way of doing it, which is to only have numbers. Okay, users can't then type in the words. The number 20. Yeah, no, it makes sense now, doesn't it? So validate. Okay, so the other way, you really need to validate what the user is saying. So, please stop thinking I like to correct people. I love to correct people. Validation means ensuring that the input data is reasonable. So whatever the user has given to the system, we need to make sure that it's good and that the processes will handle it. VCAA talks about computing validation as you can do it in multiple ways. The way the VCAA talks about it is a length check, a range check, and a type check. Okay, so let's look at what they are and how they work. So, type check. This is your classic example of typing the letters 20 or using the numbers 20 for 20. You're checking the data type. You're checking that you're getting the right data type. So an integer versus a string. okay? And there's some VB code here as an example to check that the input given is a number and not text or string. The next one is a range check, okay? So checking that the data is between two numbers, okay? For example, you might have a car, and you might be asking how fast is the car going, and that might be between 0 and 250, okay? If it's my car, certainly, yeah, it's not going to be going any faster than, well, I think physically it can't go faster than 100, 110, really. And that way, that's just another way to check that the data the system is getting is okay and reasonable, and that the processes will work. Another example here, if int class size is greater than 25, then display class is full. Please try again. Else return successful class enrollment, okay? And perhaps add a student name to a list or something like that. The reason these checks and validations are important is so that the data comes through as you would expect it to, and the processes run as you would expect them to, okay? The example here talking about class size, obviously you don't want a class of 26, so somewhere in the program it needs to stop saying, no, you cannot enroll in that class, it is full. Okay, last one is the length check. So ensuring that data only contains a certain number of characters. So an example could be a user ID may only contain 10 numbers, okay? Another example might be a student ID. It might be, 3 letters of your last name, your first letter of your first name, followed by 4 numbers. In other words, 8, length of 8. You're checking it's a length of 8. And you can see some VB code here below, basically checking that the entry is between 0 and 10. Okay. Interesting that the message box displays something different there. I'll leave that for you guys to have a think about. Thanks for watching.